Good morning. Today we will study about microstates. What are microstates? It is nothing but the electronic arrangement. Okay. For example, P2 configuration. Let us take P2 configuration. Carbon C6. Carbon Z equal to 6 atomic number 1s2, 2s2, 2p2. Okay, 2p2. Therefore, Px, Py, Pz orbital. Orbital quantum number is plus 1, 0, minus 1. Therefore, I have there are two electrons. I can put one electron here, one electron with the upspin, and I can put one electron here and another electron here. Okay, and I can also put one electron here, another electron here. Okay. Now I just this is upspin and I am putting downspin. All are down. Okay, so down 6. You will get 6 states. And next, I am just putting one up, one electron up spin, one electron down, one electron up, one electron down. Okay, one electron. So similarly, one electron up, one electron down, one electron up, one electron down, and opposite. Just invert the spin. Okay, this is up, this is down, this is down, this is up. So you have this, and in another 3 cases, you have the 2 electrons parallel. According to Pauli exclusion principle, each orbital can accommodate 2 electrons. So by following Pauli exclusion principle, these states are also allowed. So there are 15 possible electron arrangements in a degenerate orbital, in a set of degenerate orbital. What do you mean by degenerate orbital? They have same energy. For example, Px, Py, Pz. They have same energy. The 3 orbitals have the same energy. They are degenerate, called triply degenerate. Whereas the 5d orbitals, they are 5-fold degenerate. Okay. So, what are microstates? Now we are able to define what are microstates. The different possible electronic arrangements in a set of triply degenerate orbital or a set of degenerate orbital of slightly different energy. Each electronic arrangement is called a microstate. Each electronic arrangement is called a microstate. This collectively called microstates. The number of microstates for P2, there are 15 possible microstates. I have shown here there are 15 possible microstates. Now, for example, D2, can you draw the table like this? It is very, very difficult. Therefore, there is a formula given by permutation combination rules. By using permutation combination rules, the formula is obtained to calculate the number of microstates. It is the function of n and r. What is the formula? You see this n factorial divided by r factorial bracket n minus r factorial. Okay. For example, let us take P2. Okay. For p orbital triply degenerate, there are 3 p orbital. Okay. Number of orbital is 3. Number of orbital is 3, and each orbital can accommodate 2 electrons. Therefore, 2 into 3, 6. 2 into 3, 6. Twice the number of orbitals. Why? Each orbital can accommodate 2 electrons. Therefore, for example, D means D orbital, D2. In that case, 5 into 2, 10. Okay, let's see. And R is the number of electrons. And R represents the number of electrons. In this case, R equal to 2. Now, we will determine how many possible microstates. It is often asked in JAM, NEET, and other competitive examinations. How many possible microstates for P2 electronic configuration? So, here, as I said, n equal to 6. N equal to 6 for p orbital, triply degenerate, and 2 into 3 equal to 6. Number of r equal to 2. I substitute here in this formula. So, n factorial, 6 factorial divided by r, number of electrons, 2 factorial, n minus R. N minus R is R 6 minus 2. R is number of electron, 4 factorial. Therefore, 6 factorial is 1 into 2 into 3 into 4 into 5 into 6 divided by 1 into 2. Okay, 1 into 2 and 4 factorial. This is 4 factorial. Now I cancel this, and then 2, here 3, 5 into 3, 15. There are 15 possible electronic arrangements. Okay, therefore there are 15 microstates for P2 configuration. Similarly, you will be asked to find how many possible electronic arrangement or how many microstates are possible for D2 electronic configuration. For D2, D is 5-fold degenerate, 5 orbital, therefore 2 into 5, 10, N equal to 10, R equal to 2. If you substitute in this formula, 10 factorial divided by 2 factorial, 10 minus 2, 8 factorial, therefore you will get 45 microstates for P2 electronic configuration, 45. And for D10, now you try to calculate D10, how many electronic arrangement, D10, you know only one only. By using this formula, again we can obtain 10 factorial, okay, N equal to 10 and divided by 10, R is 10 factorial and 10 minus 10, R, therefore 0 factorial. 0 factorial, what is the value of 0 factorial? It is equal to 1, therefore D10 equal to only 1 microstate is possible. Only one type of electronic arrangement. In a similar way, P6 equal to 1. You can obtain the number of possible. Similarly, you may also calculate how many microstates for P1, P2, P3, P4, P5, etc. I have shown here P1 6, P2 15, P3 20, P4 15. By using the formula, you can calculate this P5 6. If you look at that, P1 and P5, and this is P1 and P5 are same. P1 and P5. This is one electron. This is only one electron it has. Here, only one hole. It is considered as a hole in this case. Therefore, same. They have same number of energy states and also same number of microstates. Same number of microstates. P2, P4, okay, and similarly D1 and D1 is number of electron 1 and D9 number of hole 1, okay, so here 2 holes, 2 electrons, 2 holes here, similarly D3 and D7 are related by hole and electrons, and D5, D6, and so these are how related. This is very, very important. They will ask many questions in competitive examination. So please understand what are microstates, what is the formula used to calculate, and if you understand the basics, you will be able to answer any questions asked in your competitive examination. Thank you for watching.